Adrian Collins. This is task one, part one. Uh, on To describe a straight line motion, first you are given 2 points. You find the slope of the 2 points via x y2 minus y1 over x2 minus x1. Then you get the y-intercept by subbing one of the points back in, including the slope, and you reorder the equation to get c on its own. Then you have the equation of the 2 points. You find the direction of the two the points. We are given 22 minus 3, 12, 17. So 22 to minus 12, 2 plus 12 is going backwards, so it's got to be a minus direction. To find speed, you have x1 minus x2, which is 22 minus 12, and then over the time taken to get to that. And in the question, it says 20 seconds later, so I sub in 20. That comes to 0.5. Then you get the starting point, which is going to be 22. And for xt, it's going to be the starting point, then the direction, then the speed multiplied by time, t, which is time. So that's my equation for it. But then to put on the delay as the movement starts 3 seconds later, you change t to t minus 3. And then I reordered the sum to this. To get the y variable, then you just sub the new x t minus 3 back into the old equation, and I get t minus 6 as a result. And that's the new line movement here. So a recap: determine the straight line path. You get the equation, the slope, then the the y-intercept, and then you build in time, you look at the x coordinate, you find the direction, the speed, and then the starting point, and so on. For wave type motion, then, for an x, if you have a cos or a sine in the x variable of a point, it will have a vertical wave, such as this. Since the sine is in the x, it's going to be going horizontally. And the y is just normal. It's at a constant. But if the y has a cos, it'll be a vertical wave, such as it. A horizontal wave, such as this. Such as this. Cos is in it, and then in the x it's just a constant. If cos is in the variable, the starting point will be at 1, whereas if sine is in the variable, starting point will be at 0. To change the speed of the slope, you just multiply the angle, the angle inside the cos. So for this, it's sine radians a3, so it's normal. But then in, say, I don't have an example of this one. For bounce type motion, we're asked to show it in vertical. For horizontal x, you put the cos or the sine inside the x variable, such as this, and the movement will move left to right, where and the y will stay at a constant. But if you change this around, it will have a horizontal movement where the x is constant in the one spot. Instead of going this way, it'll stay in the one spot on the x, and the constant will go up and down. And the cos or a sine doesn't affect anything on this. For circular motion, we have part 2 of the question, which is an object is initially at 3 and takes 180 seconds to complete a circular movement of radius 4. So we have a formula here which is a sine bt plus d plus cx and so on. A is the radius, so if we multiply sine and the angle inside by a, such as this time it'll be 4, and then b is the speed. This wants 180 seconds to complete a movement. Normally it's 360, so we just multiply it by 2, speed of 2 to double it. And then we are given cx, which is the center x variable, and the center of this movement is -1 in the x variable. And then cy is the y variable, which has got to be 3. Then we have dx and dy, which is the starting point, and it initially starts at 3, so d is going to be always the same of 3. And then we have time. So in my movement, we have the formula. We have sine, which is in the cos, and sine, which is in the x variable, and then cos in the y. But we want an anti-clockwise movement, and so we put cos in the x and y in the sine for an anti-cos movement. So I put in my formula: 4 multiplied by cos, 4 being the radius, cos being anti-clockwise, multiplied by radians, then 2 for the 2 times double speed, multiplied by t, which is 0 right now, and then plus 3, which is the starting point, and then plus another 3 to the final thing to get the center where the circle starts. So we can show it's a starting point's there, and if we slowly go through, it's going in an anti-clockwise movement. So we can go up to 150, and then it stops at 180, which is double the speed of a normal. And if we go to 360, it would have done a second rotation. Thanks. This is me done.